what's up? Let's see. Wednesday afternoon, day 3 of RailsConf. Everyone's a little sleepy. So I'm going to wake you all up with the most insane, mind-blowing topic I could ever conceive. I mean, when I get neck deep in XML and my favorite Turing-complete Yaml files, I just go crazy. So hence, 40 minutes just for you. So I'm Beau Harrington. There's my amazing GitHub profile, which I think has 1 repo on it, and then my Twitter, where I make jokes about things that have nothing to do with software. So first things first, I noticed about 3 minutes after I submitted my talk that the magical 2 words, configuration management, to a lot of people, especially our DevOps crowd, means chef and puppet, and this is not what this is. So here's your chance to escape. All right. Next, I'm going to steal a phrase. I heard this from Chris Kelly, I think, on Monday, and I probably badly paraphrased it, but this is intended to be just a quick... okay. Anyway, this is a conversation about ideas. It's not a strict prescription as to what you have to do. Just going over some things that have worked for us, some things that we haven't actually put into production on all of our games yet, but have still shown promise, or things that have been cool ideas for personal projects. So it's going to fiddle with a cable or something. And then, in the meantime, I'm just going to go on, if you don't mind. Yeah. Okay, cool. So I'm Chief Software Architect at Kabam. We're a company that makes mobile and web games. That includes the #1 top-grossing iOS app of 2012, Kingdoms of Camelot, Battle for the North. Of course, we are hiring, and that's all about that. All right, so what is configuration? You guys are missing the best slides. Well, you can probably start off with some of the contents of your config directory in your Rails app. We've got database.yaml here. This looks like configuration, right? We got host names, we got usernames and passwords and timeouts. Those are my favorite. Then, some kind of newer hotness, feature flags. We want to be able to turn features on and off with just a simple deploy or otherwise. So we can flip the search box or append the request time to request very simply and easily. Yeah, that looks like configuration, right? How about translations? Those live in config. I don't really know why, but they're there. It's so frequent that we have the people that are going to be doing internationalization and translation for us on bigger teams and bigger apps. They're all software engineers, so this is cake to them. So yeah, we've got, all right, we're going to translate some strings. That's great. I guess that's configuration. I hate this so much. For some reason, we're putting view logic into our models, but you know what? I'll take that. It's configuration. That'll work. How about if you're playing a game, free-to-play game or a game for mobile, web, something like that? We always have quests, right? I want a reward when I finish one of those quests. 50 coins. All right. More configuration. Okay. Now I'm in my production.rb file. Now we got some assignments going here. We got second-level access of variables. Might even see a block or two. Okay. So configuration is basically, and very annoyingly, everything you want it to be. And for our purposes, we're going to say today that it's values that you may want to share or to change. And I'm, again, intentionally keeping the definition of it super broad because you've heard the phrase, code is configuration or configuration is code, and the line is extremely blurry. So if it doesn't have a precise definition, that's okay. So why do we care, or I guess why do I care about configuration so much? So I lied. I am going to go back to my corporate life for a second. So Kingdoms of Camelot, Battle for the North. It's a real-time, it's a strategy game with a shared world. You can have up to, I think, 70,000 players in a single world, and they're all fighting over the exact same resources. They join alliances, they fight each other, they kill each other. It's quite exciting. And so part of that is you have a kingdom, and your kingdom has lots of little buildings. There's 15 different kinds of buildings, in fact. And each of those buildings can get leveled up gradually over time We have 10 plus levels of each building. And then each of those levels has 8 different requirements, including different kinds of resources, a certain amount of time that needs to pass, and a prerequisite for buildings that have already been built. So just for buildings, that's 1,200 plus values that you have to deal with. That's 1,200 integers and a couple strings, but mostly integers. And that's just buildings. We got all this other crap, too. Research, nights, battle tuning, NPCs, items, quests, which gives us a grand stinking total of over 25,000 values that we have to deal with for one game. I'm not particularly relishing copying and pasting stuff into a YAML file for somebody out of an email, or worse yet, out of a Word attachment in said email. So let's get serious. When we're going to put out new features or even configuration changes for our games, we have 2 levels of QA that we need to do beyond just our normal automated testing. We have technical QA, but we also have playtesting QA. Everything can be working perfectly from a technical standpoint, but from a playtesting standpoint, if we release something that nerfs a very valuable item or makes something cheap very overpowered, that's just as bad, if not worse, than a failed deploy on a technical basis. Because the nature of our games, they're free to play, which means you can pay $0 or you can pay more than $0 for the items that you have in your game. So if we mess up the configuration values of those, we are basically nuking people's investments. And we don't want to do that. So we want to have a process around deploying new configuration that's just as rigorous as when we're deploying code. So now a point, an agenda. So we're going to talk about, all right, we have a context, right? We have an environment, we have data centers, things like that, where we're going to be deploying. That's really relevant to how we're going to configure our applications. We also need to think about how we even generate those configurations in the first place, and then how we're going to push them out onto our servers. Finally, what is all this going to do for us? What is it going to enable us to do? And what are some other things that we can explore, other software packages that we can look at? So let's talk context. Let's actually just make our own game instead, right now. So it's a really cool spec. It's a really cool idea. I think it's going to make millions. You're going to click this puppy, and you will get 10 gold coins. And sometimes you will get a prize as well. You'll get either a yo-yo or a piece of candy. So let's take our first stab at this. We've got the puppy click class. Yes. So we've got 3 beautiful constants there: coins per click, odds of winning prize, and an array of prizes. I feel like we've done pretty good so far. We've avoided any kind of magic number. It's not terrible, right? But at the very least, we get the damn things out of source. If I was happy with this, I wouldn't be yammering on about this for 40 minutes. So let's pull them out and do a simple config file. We'll call it game.yaml and config. Let me just go ahead and tell you right now, yes, all the examples in here are in YAML for the sole reason that YAML takes up less space on this dear screen here. No particular affinity to it. So we've got our little game hash here, and then we've stored everything as part of the YAML data structure. Awesome. Now everything's out of source, and it's in a single place in config. That's really good because it's natural that we're going to start looking at the config directory first when we're looking at configuration. So what about when we need to actually care about the Rails.env? I mean, this seems pretty basic also. This is a basic pattern. We've got things split by development, test, production. It's kind of gross, though, because we're repeating ourselves a little bit. So when I'm in development, I want to make sure that I win a prize every time because I'm super impatient. My time is super valuable. So I've set the odds of winning a prize from 0.1 or 10% to 1, 100%. And then all the things that are the same, I've had to replicate for development and then test and then in production as well, if the screen were bigger. So let's move on a little bit to composite configurations. I think these have like 7 or 8 different names: composite configurations, cascading configurations. The same kind of concept in CSS where we'll have a core set of configuration, and then we will apply transformations on top of it based on a weighted set of factors. And so the first one, and pretty much the only one that gets used usually in this kind of configuration, is the Rails environment. So we've got all the core values, and then anything that we're overwriting We're just going to state those values in the sections for those particular environments. So we've got odds of winning prize 1 for development and then nothing else. For test, we want to make sure that we're testing the screen properly, so we change the image from a piece of candy to a screen test. And so, yeah, we're dry. We're not repeating ourselves. That's great. So, yeah, there you go. There's an example of all the wonderful goodness that you can have there. But why stop at Rails.envs? You can do a lot more with being able to infer information about the context of your deployment, and from there, make bigger changes. I know a lot of people are on AWS, and if you're doing a multi-data center deploy, for example, or multi-region deploy, you'll need to change the server names that you're using for each of those data centers. If you have certain machines that are more powerful than others, you might want to change the settings if you're in a heterogeneous environment. You might want to assign more specific roles as well to machines. So how do we do that? Well, we can just pull different YAML files. And then, so we've got the core, and then we've got the environment, so production or what have you. We have the region, so we'll say US East 1, God help you. Then we've got, in hosts, we'll take the host name of the machine as well. So we'll go through and we'll load the contents of each of those YAML files. And we'll do a deep merge on what starts out as an empty hash, and then we keep merging in the contents of each of those. So you can see that the further down the file list you go, the more likely you are to win, so to speak. They'll be the ones that have the highest priority. So anything that gets set in a host-specific file will always win. We can go on with this concept. We can basically have tags in which you can pass a tag through an environment variable and then load up a different configuration. This is useful for if you need to do kind of transient, quick loads of different sets of values. If you're having a crisis or something, you need to pull up specific debugging values, or you want to canary some new code. You can also assign role-specific configurations this way. And again, the code is pretty simple. Just pull in the list of tags, split them by comma, and then we load in each of the relevant YAML files. And that's it. So there's already a gem that encapsulates a bunch of this stuff. Rails config. I'm sure there's more. There's a whole lot. It seems like the killer feature for all of them is being able to have dot notation instead of having to do hash-based access. Which I guess that's important. So the Rails config gem will also do hot reloads of settings files for you. So if you do settings.reload, it will suck in all the new values. It'll reload all the files there for you, so you can do some interesting things with pushing new configurations without doing a code deploy. You can also do the composite configurations that we talked about. It also has support for a set of developer local settings. Well, it's more of a configuration or a convention than anything else, but with the get-ignored file has settings that are specific to you. And then you don't have to worry about committing those back up and messing anything else up. And there's where you can get it on GitHub. So all this is great. We now have a little more sanity, a little more clarity, and more predictability as to what configuration settings are going to be applied when. And yet, I can't give this to a non-engineer. I mean, I could, but I don't want to. All right, so our settings are aware of their context and environment. That's great. But everything is still in source, still tied to a commit, still tied to a deploy, and it's inaccessible to any other apps. If you guys have been paying attention to all the other talks this week, I'm sure by now you all have completely reconfigured and refactored your applications so they're all beautiful, sparkling, service-oriented architectures. And so if we have configuration stuck inside of a single app, it's going to be extremely hard to extract that. And you're going to be doing things like putting configuration sets into gems and passing them around. And don't really think that's the best pattern. And yes, of course, still inaccessible. It's non-engineers. So let's look at how we're actually going to bake these configurations, or build, or bake or build these configurations. The requirements from our end, we want to decouple the process of generating the configuration entirely from the application and the repository itself. Do you guys remember how we used to do software, like before we had scripting languages all over the place? We would do builds, and the build process would generate an artifact, and then we would take that artifact and put it somewhere. And so that process maps really well to how to handle complicated configuration changes. We can take whatever data source we have. It can be something that's entirely different than YAML, that's maybe more appropriate from an editing point of view, then we can have a process to turn it into a YAML file or a JSON file. We can version it, store it in a central repository, and then have some shenanigans to deploy it in a way that's separated from that overall application itself. Sounds like a good job for a web app to me in terms of generating and holding and making accessible to users individual configuration files. We can also hold a whole bunch of logic in that web app that we don't want to shove into our actual applications. Things like access controls, individual auditing, making sure that we keep a list of every single change, and then any kind of bounds or sanity checking that's in there. And then for those of you in larger corporate environments, you can put in God knows what else. So it's a really simple principle, I think. You have your dimensions, so you've got basically core, and then you can do an environment, you can do AWS region, tag, anything else that we've previously specified, and then the value for that, whether it's core, dev, test, production, US East 1, whatever, and then simple key value. And yes, it would map even a little more nicely to a document store. So why don't we just pull it directly from the database? Well, the database is precious, right? Compared to everything else that you have. If you have a decent architecture, you can spin up more of anything else except database power. And yes, you can say that you'll have, your horizontally scaling databases that can go, multi-data center and all that stuff. I wouldn't trust it compared to being able to do simpler applications or simple operations, just pulling things from files. And also, if you're having hundreds or even thousands of apps, I'd rather do thousands of requests against a static file going through Nginx or S3 rather than trying to pull all of that information through your precious database as well. But if you don't have tons of load, it'll work fine. So our build process is we're going to take our configuration values, however they're stored, and we're going to transform them into a single YAML doc or what have you. That's our artifact. We'll also take note at the same time of the builder. We'll set a monotonically increasing build number, timestamp, and then we can enforce a changelog as well, which is actually really handy. And then we can include a checksum within there. Especially people who are quasi-technical will love to go into files and make changes and not annotate them. It's really a pain in the butt when those files are not under version control. So with a checksum, that's not going to happen. So, quick example. Let's give double coins. Let's give 20 coins every time we click on this puppy here. We're just going to go in. We're going to change our value in our configuration table. And then we'll run our build process. And there's our YAML doc. Awesome. So here's the information about our actual artifact. We put in the build number and then like a tag name for it basically, and then a checksum. And then we've also got it on an asset server as well. So if you want to pull this particular version of the configuration, it's there for the taking. And that way you can experiment with it, not just in production, but any other environment as well. So how do we get that artifact into a particular environment? We can do a promotion process where we basically will map a single build artifact, a single configuration artifact, to an environment or a region or something else. So we basically have, we end up with the same kind of overall end product, which is we've got directories based on environments and data centers and regions and tags, and there's YAML files in them. They're just on a remote disk somewhere or on a remote web server somewhere. And if you build your tools correctly, you can do this promotion process. Well, any user can do this promotion process. It doesn't have to be just an engineer. So our settings are where, their context, and environment. The settings are outside the repo. They're accessible to other apps. You can have any app you want, access those URLs. The changes are accessible to non-engineers, but we can't deploy them yet. So how do we do, I guess, the final step, which is going to be the deployment process for all this stuff? So got a title slide for it even. All right, so a release process. We're going to be running, standard tests and continuous integration against the configuration. We'll run both QA and playtest QA against a running instance of the application that has that config. And then everything checks out. We're going to deploy to production. So we've got the same kind of deal. We're going to loop through our Rails.env, our AWS region, and our hostname, and then we will go get that file from our config artifact server. And for each of those files, we're then going to do that same deep merge so that we have that composite set of configuration. But you still have to restart. I don't want to restart. And if you go check out my lightning talk in about an hour and a half, you'll see that I really don't like to do restarts. So what we can do is, if we're running on a modern interpreter, we can spawn a thread in the background to poll for updates to that configuration file or set of configuration files. A really good mechanism for this is Celluloid, which is a library that basically brings actor patterns into Ruby and works great on both JVM and Rubinius. And you can spawn a Celluloid worker that will run on a timer and will go fetch your configuration values. And then, every 30 minutes, we'll keep recreating your configuration. As long as you write it in a thread-safe way, then you'll be able to basically just sit there, and any new artifacts that are promoted to production will automatically get brought into your app. This doesn't work well for applications that are running on MRI that have a global interpreter lock. It's also kind of gross in multi-process environments. That means unicorn, because once they forked, they forked. So the big thing is that if you're going to be doing this, you should be on a modern interpreter, and you should try to be kind of thread safe, because trying to do in-place updates can really get you. So here's an example. I think it's pretty intuitive, even without in-depth knowledge of the Celluloid library. So we'll spin up a worker, and then refresh will pull and assemble all of the configuration, just like we've seen before. And then we have a timer that'll run every 30 seconds, minutes, and refresh those values and then reset the timer so it keeps occurring. So what you can do is then you stick those, your configuration accesses behind a method, which will basically make sure that any accesses are thread safe and that you're also getting the latest value. So when we deploy our change to increase the number of coins per click from 10 to 20, once that configuration file is promoted, all we have to do is wait, because that timer will go off and reload all of our configurations. And then the next time we want to access it, there you go, the new value is there. So it's good for simple things, but then there's a problem if we want to try to change more advanced sets of configuration. Well, let's see. What if we need to break a cache? So we can put an on-change hook on when that particular configuration value changes. That can be a string, right, X, something like that. And then once we get that new value, we can do a logger warn statement. We can break caches. We can do all kinds of things. And this way, we're cognizant of what's going on with updates and changes to our configuration. This is really handy for more operational side of the house type things, like if we want to add or remove Memcache servers from our pool. We can, anytime the list of Memcache servers changes when we're polling the configuration, we can go ahead and reinitialize the Rails cache client to be a new copy of whatever your client of choice is with the new list of Memcache servers. So your operations guys will probably be a lot happier with you, because they will not have to harangue you and try to find you to take out half of the Memcache servers to do maintenance. So why have I been talking about polling and not pushing the entire time? Well, with polling, basically you're keeping the burden of what happens when things go wrong in the same place as actually, it's the same code base and same source as the code that's trying to pull and pull the configuration updates. If we have a failed poll, then we can easily rescue that timeout or whatever, and we can nuke the worker, or we can take other steps. We can preserve the original configuration. We can do lots of different things. But if we're trying to do push, and the push fails, if I can't access a machine from my control server, then I can't further communicate with it in order to tell it to do anything else. So it's going to continue to just kind of be a zombie and keep chewing through data with whatever its original configuration is. And so at that point, your responsibility is in the wrong place, and you can't do anything about it. So that's why, for the most part, you want to do polling instead of push for this one, although I'll talk about an exception in a minute. All right, so the config is out of our source. That's awesome. We've got non-engineers that can build and deploy, even better. We've got configuration that's shared across our just massive constellation of service-oriented services. We can update the configuration live without doing any restarts. And we can test those configurations easily because this doesn't just work for production. You can set up an arbitrary amount of environments or hosts or whatever you want. And then you can easily have whoever is responsible for those configuration updates, a game designer or place tester or someone like that, can easily push that configuration to a test server and test it themselves. You're not even involved, which I think is a big plus because I know that everyone in this room has been bugged for quite a lot of configuration changes and so forth by people who can't do it themselves. And then if you design your toolset correctly, you can also record any possible changes. You can audit everything. You know exactly what's been going on. And you can actually add more than just having your configuration files, and Git will be able to supply to you. So this is all really good for games. We've got thousands upon thousands of configuration values, and now we have a framework and basically peace of mind when it comes to managing them, making sure that we don't screw things up. What else can we use this for? Well, it's really good for pushing out lots of A/B testing. If you want to get lots of experiments out there, this is a good way to make sure that all of your experiment data, in terms of what's going to be changed, can easily be pushed out to all your machines. Also, this is really good for dealing with ITN and translation management. Some of our games are published in 15 languages and have tens of thousands of strings each. Don't really want them mucking around in config locales. And so with this framework and setup, we're able to have them use whatever tools that they like and have become used to, and then we work with them to create a simple kind of tool that will bake that into a YAML file that the game can then consume on its own. And finally, feature flags. All right, bonus non-Ruby content, because we still have a little bit of time. These are 3 things that I think are very influential and very cool to check out, even though none of them are strictly Ruby per se. First of all, how many of you have been keeping up with the Netflix efforts with open sourcing their internal API? Everyone's hand should go up. Their stuff is the commitment that they've put toward pushing the envelope and pushing out source for how to deal with not just working in the cloud, but also working with kind of the mundane problems, like configuration management. We've gotten a bunch of ideas from their configuration library, the composite configuration library called Archaius. And it is in Java. You can use it in JRuby. And that's just the start of the kind of Netflix ecosystem of Java plugins and Java libraries. And they've also demonstrated a commitment to helping their stuff run with other JVM languages like JRuby as well. There's also Zookeeper. Zookeeper has a reputation for being kind of tough to run into production, and I won't dispute that. But it is solving an extremely hard problem, which is a strongly consistent cluster synchronization service. So if it basically just supplies some basic primitives of sets and puts and watches and things like that, and you can be guaranteed that they will occur in the order that you specify. Why this is relevant to us is because the watch primitive on Zookeeper allows us to basically get a stronger reliability guarantee for being able to get push updates to configuration. And so that leads into a very interesting Python app that's based on Zookeeper called Jones, and basically takes a lot of the concepts that I've been talking about in this talk and combines them with Zookeeper to allow you to instantly push configuration changes into whatever hosts are hooked up and watching those specific keys on a Zookeeper instance. All right, I think I have some extra time. That's it. You get another gratuitous puppy picture. Cool, you're all experts now. Thank you very much.